I'm Ellie. I am a data scientist working on the gov.uk website at Government Digital Service. And I'm here today representing a really multidisciplinary team who worked together last year on the work I'm going to talk about today, which is developing the topic taxonomy for gov.uk. And that team included people ranging from user researchers to content strategists, developers, and data scientists. So for those of you who don't know what gov.uk is, does anyone here not know? That's pretty good. Okay, it's the nation's website. It's where people come to carry out like really common tasks and services like check your MOT or apply for a driving licence. But there's also loads of other stuff on there that government departments publish, like consultation reports and medical safety alerts and weird stuff like that. I mean, a really diverse range of stuff on there, and there's a lot of it. And because we're the kind of interface between citizens and government, one of the main interfaces, there's a really important dual role that gov.uk has, where we need to make sure that people can understand government. And we try and do that by making our content simple and our user journeys really intuitive. And we also try and help government understand people. We have over 1 million users of the site every day, and we can use the insights from their kind of travel across the site to understand what their needs are and see where there is unmet need. So in the first 3 years that gov.uk was created, they had this big kind of challenge to co-locate lots of websites under a single domain. And in that time, they closed down 1,882 separate domains, saving £63 million per year on website costs alone. And as a result of that, there's quite a lot of weird content that came with sort of legacy organisations sort of structures. And it was done so quickly that there wasn't a good kind of information architecture underlying that. And so the phase we're in now is trying to consolidate that content and make it kind of have a good data backend. And one of the really important parts of that consolidation effort is to develop this single site-wide taxonomy across the whole site. And the original reason was to help with site-wide navigation, but actually our team's vision set last year was this, and it was set to make it more about having an additional piece of metadata to make the company more data-driven, so we can use that for lots of things as well as navigation. So we didn't want it to be just about navigation. And sometimes when decisions got a bit complex, we'd fall back on this vision in the team. So back in the early days, before our team got together, there were some user-centered approaches to classifying this content. And users identified 21 different themes across government, and this is one of the themes that was really extensively tested with users, and we call it a branch in the taxonomy. The taxonomy we have is in a tree-like structure. And you can see the sub-branches in blue. And this approach was working, like the quality of the content was really good, but it was taking way too long, and it required way too much input from government departments, and it was just unsustainable. The projected time to do it was kind of forever. So a new approach was needed, and that's where we came in. We took a really radical approach of saying we don't want it to be perfect, we just want it done. And when it's done, we can start to change it and make it better. And we had a pitching session of ideas of how to do it, and ultimately what was decided was to try and merge some of the different grouping systems that already existed amongst from different areas of the taxonomy, and try and create a single site-wide taxonomy with that. To be honest with you, I don't really know what these groupings are or why they exist, but the content strategist did, and she, within 2 weeks, brought it all together in one big spreadsheet, everything in a new tree, and this is one representation of that tree. So there's all the branches at the top. It's 5 levels deep, and there are over 1,300 individual taxons in the tree. And at the same time, tools were developed internally to manage that taxonomy, and this is a screenshot of one of the internal teams' internal tools. This one is so you can like delete a branch or edit its name and see how much stuff is tagged to it and that kind of thing. And then this shows what the metrics were like at the once that had been completed. So because some of the content had come with those taxons when they were merged into that tree, we had half of our content already tagged to the taxonomy. And that left us with the challenge of tagging the other half, but also gave us a really clean supervised machine learning problem, because we had the labels, the word supervised means we had the labels already on half of our content, so we just needed to learn the patterns in the data that met those labels. And so we aimed to do that, to tag the remaining 50%, but also in the future to suggest tags to publishers while they're creating new documents or updating older ones. And this slide is really just to set out the machine learning problem for you clearly. So on the left, you can see what we did have, the labeled items, and you can see that items could have as many tags as they wanted. So we had a range up to like 400 for one content item. And then in the middle, the stuff that we didn't know what the tags were. And on the right-hand side is the level 2 taxon. So they're the blue kind of links on that education page I showed you. And that's what we were going to predict to. And when we first started, there were 214 of those. But every day, the number changed and the classes themselves changed, because the taxonomy was constantly iterating whilst we were working on this problem. We also had a really big problem with class imbalance. So we had a range of two content items per topic to 17,000 in one class, which is really difficult for machine learning algorithms to contend with. And we had to do quite a lot of work to balance our data out. So, bringing you to the data. This is what a front-end page on gov.uk looks like. And like many machine learning projects, much of our work was about producing a data pipeline. So we needed numerical vectors that we can chuck at machine learning algorithms and see how well they do. And the back end of one of those front-end pages looks a bit like this. This is a JSON representation of all the different types of, in fact, a truncated bit of it. There's a lot more. But what we did was concatenated all of the textual fields, so the title, the description, and the body, and we put that into one big text chunk. And then we converted those textual words into word vectors, a process called tokenization. And we also created vectors out of some of the metadata at the top right-hand side of the page, which we also used in the model. So some of it, like you've got the document type there, when the document was first published, and which publishing application was used to publish the document. So once we had these lovely long lists of numbers, our word vectors, one for each document, we were in a really good place to just throw those numbers with the labels at some algorithms and see how well the algorithms performed. And we tried out lots of different algorithms, but we found that the baseline convolutional neural network outperformed them all. This is a kind of a sort of representation of the architecture of our baseline model. The neural networks are kind of like inspired by biological neurons, but what's really good about them is they're able to model quite abstract concepts like text and image, because they've got a lot of flexibility in the way that they fit the patterns in the data. And so they're really good for this kind of problem. The deep learning comes from how many layers there are. So as you go from left to right, each blue box is an additional layer in the model. And it's become really fashionable recently because computation advances allow you to train those models much more easily. They're not new, it's just that it's new that you can train them so easily. And the word convolution comes from a particular type of layer in the architecture there, where you kind of perform a little operation on a small bit of your input, move along, perform the same operation, move along, perform the same operation, and so on across the entire word vector. And so it's a little bit like reading the document. So you're getting an essence of sequence and context of the word, which you don't get in quite a lot of the more basic kind of bag of word type data processing of language. So we were quite pleased with the metric for this. But when we looked at the qualitative results and we put them in front of content strategists and user researchers, it wasn't so good. So this news story here was classified as counter-terrorism, and there were quite a few other really bizarre mistakes, and so we knew it wasn't good enough for the cut. So we went back, and I think it took us 2 weeks to get to that stage, and at this point we probably put in the biggest brunt of the work, which was optimizing the model and also tidying up the data pipeline. So we'd done that quite messily at the beginning, and we went back and put a lot more work into that. And one of the biggest improvements we got at this stage was kind of counteracting the problem of overfitting. And overfitting kind of is analogous to if you're trying to sit a GCSE exam and you learn all the results to the mock paper by heart. And then when you get to the actual exam, you don't know how to answer the question because you don't have any generalized knowledge. You've learnt the answers to questions that are no longer there. And so we talk about it as learning the noise in the data rather than the signal that you're looking for. And there are a few approaches for tackling that problem, and they both kind of fit around the idea of slightly constraining that flexibility that I talked about within the neural network. So one way you can do that is called dropout, where you just arbitrarily stop nodes working in the network so that it can't so freely fit the pattern. It has to sort of it's a bit more rigid. And so it tends to pick up the strong signal rather than model itself around every corner. And another thing you can do is kind of normalize your inputs so that you don't have the outliers causing a big deal. And we did loads of other things with the hyperparameters, tried out quite a few values for things like how long our sequence lengths were and things like that. And played around with different inputs. So our final architecture looks more like this. And you can see that really the main difference is we just chuck in a lot more inputs in the final layers. And we found that that also had quite a lot of benefits. So you can't see it's too small, but you're not meant to. But on the right-hand side, you can see that we add the title and the description again into the model at later stages. And that's to give those more important kind of bits of what's this content about, the title hopefully tells you, a bit more weight in the classification. And we found that worked quite well. And our global metric was much, much higher. But more importantly, our qualitative results were looking really good. So we got some random samples out and checked them. The only place we had problems were in agreement with the metric we were using, and the taxons that had a low metric, we didn't think that the results were good enough, and so those two taxons we didn't take any of the predictions to. And so combining the model and some hard coding rules, we ended up being able to tag, and the answer is actually 96, even though it says 87, 96% of the in-scope content for gov.uk. So we were pretty happy with that outcome, particularly as the stuff that wasn't tagged appeared to be kind of quite old news stories, so it wasn't very important for us to organise. So it was looking good. And so now that's the machine learning bit aside. I'm going to talk about how that has impacted on gov.uk, on our users. So those high-level pages now have been converted into something called topic pages on the site. And there's lots of different types of things, like there's services and guidance for that topic page, and so you can use that to navigate. But you can also get email alerts for a particular topic if there's been an update or to anything in that thing. And of course, we do also use it for the contextual navigation. We have to make sure that our site is accessible to everybody, and even though we know not that many people use navigation, we've got to think of everyone and when we make our site, and so we have breadcrumbs at the top and related content on the side. And we've got a lot of interesting feedback from publishers who are now tagging to the full taxonomy about how that's working. And so some of the benefits are we've got this streamlined information architecture which no longer relies on the kind of structure of government. So its topic is about what's the content about rather than who published it. So as a result, departments are having to talk to each other and kind of redefine these boundaries together rather than just publish everything they want and deal with it later. And so we're possibly reducing the duplication of rubbish content going online. And again, you get this kind of overview of all of gov.uk's work. Our data science team has grown as a result of this work, and we're being able to do a lot more experiments with different ways of using data science to help the organisation. And we think we learned quite a few things from this project. We found that the principles of Agile really work for us in this project, going for fast over perfect, working in a multidisciplinary team. And there's loads of stuff documented about this at GDS, and we really kind of think that was a brilliant for this project. Could still be going on the manual approach if we hadn't. What we could be better at is creating some clear hypotheses and sticking to those throughout, which we didn't do very well. And we also slightly lost touch with our stakeholders through the process because we were kind of really moving quite fast and we became quite sort of introspective. And so some of those changes that we made, we didn't really communicate very well with departments, and we had to kind of backtrack a bit on that at the end. And what we're looking forward to doing is perhaps doing, as I said, the suggestions during publishing, working out how the taxonomy is going to be governed now there isn't a team that looks after it. So how do decisions get made about when to split a taxon or create a new one? There's a new concept that's arisen, like Brexit or something. So that can happen. And also it would be nice to be able to measure like how much the work has impacted on findability for citizens and for our content management, like the data-driven principles of content management. And that is all I have to say. So thank you very much.
Thank you. All right, any questions for Ellie? Yes.
Do you have any scalability issues? For example, how many data you can process? So
we couldn't run it locally, the algorithm. We had to run it on AWS instances, and we ended up having distributed kind of across several GPUs, and it took, I think, across 8 GPUs, it took about an hour and a half to run it. So it's quite big, yeah. It's not colossal.
It's for training or
for training, yeah. For inference, it's fast, yeah.
How fast?
I've never timed it because it's fast enough. Like for a single thing, it's very, very fast. For the test set, it was probably 10 minutes. Yeah, it's inference fast. Yeah.
Any other questions? Coming to you.
What do you think? Is it possible to use this network to make your resulting taxonomy as labels for further learning? I mean, if you have external content, to use this taxonomy as labels to make predictions.
So are you saying that, if I understand you right, you're saying that if you've got content that is not already in, it doesn't fall under any of those concepts, can you introduce a new concept?
Yes, actually.
No is the answer. So one of the things that you have to think about really carefully when you're doing a classification problem is that the data you train on has to be representative of the data you're going to predict on. So if you get a kind of major shift in your data over time, you need to retrain your models and make sure that they are generalizable to what is currently in your data. So you would need a different type of model to kind of sort of curate the taxonomy, if that's what you're asking. One thing we did wonder is that if you could, if you found that there are documents that are not fitting, there's content that's not fitting at all in any of the taxons, maybe that would be an indicator that a new taxon would be needed, but it wouldn't give a new label to it. It would just say, this is sort of below our probability threshold for any of the taxons for being in them, so that this content is kind of unclassifiable in a
You think it's not possible to be some kind of semi-supervised approach to achieve further learning?
Not with this algorithm. Yeah, you'd have to do something else for that. Yeah.
Okay. Thank you.
Yeah.
Thank you. Can we have another round of applause for Ellie, please? Thank you very much.